function. What is the starting point? How do we start? We are asked to graph. We are asked to find if it's continuous, if it's differentiable. So what is the starting point? Anyone remembers?
Domain?
Yes. So first I change this into negative infinity, -1. Then I change this into -1, 3. And then I change this into 3 to infinity. Awesome. Can anyone give us the domain of this function then?
Negative infinity to infinity?
Yes, because nothing is missing. So these numbers have to be in the domain. 0 has to be in the domain at all times. Okay, so between these two, I have 2x minus 3. Between these two, I have 5. And between these two, I have x squared minus 1. Under -1, a bracket and a parenthesis. Under 3, a parenthesis and a bracket. And next, I will plug in some numbers. Let's say -2. -4 minus 3 is -7. Let's say -1, so I get -5 inside the bracket. Well, there is nothing here. 5, 5, 5. I plug in 3, that 9 minus 1 is 8. And I plug in 4, 16 minus 1 is 15. I know clearly that the limit from the left, if I'm asked, is -5. The limit from the right is 5. What is the limit from either side of -1?
Not exist.
Excellent. The limit from the left is 5. The limit from the right is 8. The limit from either side.
Does not exist.
Perfect. So we already know that at x equals -1 and 3, f of x is not continuous, which means not what?
Not equal.
True. But if it's not continuous, automatically it's not.
A function?
It is a
Or
function.
a limit?
Nope.
I think does not exist.
Nope. It exists. At -1 is -5. At 3 is 8.
Undefined?
Nope. This is a key word that we learned in this chapter. Very important word. I'm going to give you a hint.
You mean DNE? Differentiable.
Very good. If a function is not continuous, cannot be differentiable. Very good. Awesome. Thank you. Very important concept. That's what we discussed in this chapter, differentiation. Good. Let's graph it. So it goes to up to 15. Okay. -2, -2, -7. -1, -5. Full point. -1, 5. Open point. 0, 5. 1, 2, 3. Open point. 3, 8. 4, 15. But I know it's a quadratic function. What about the range of this function? Can anyone give us the range? from what?
It's not negative infinity to positive infinity, is it?
It's open here.
-5 to infinity.
So
Negative
negative infinity till what?
-5.
2, 4, 5, minus 5, close, union,
From -1
union,
to
union.
Yeah.
We union what?
to -1 to
Union what?
just 5.
Good, just 5. Union,
8 to infinity.
that's it. Good, that's it. That's the range.
Where is 5 now? Oh,
When we talk about the range, we imagine that we cross the function with horizontal lines.
I got it now. No, we missed that.
So from negative infinity, if I cross it, it will always cross till 5, but then it will not cross. It will cross again at 5, but then it will not cross. But then it will cross from 8 to infinity. So now back to this function. Is it okay? So now let's determine the derivative. The derivative for this is 2. I'll put this in a minute. The derivative of 5 is 0. The derivative of this is 2x. But we know that the function is not differentiable at -1 and 3, so I have to write x less than, not equal to -1, -1 less than, greater than -1 less than 3, and not equal to 3 because the derivative does not exist. So this is the derivative, very simple, very easy to differentiate. But I know that at -1 is a jump. I know that at 3 is another jump, and the function is not continuous. So if it's not continuous, it cannot be differentiable. So I can never put the equal symbol here or here or here. What is the definition of continuity at a point? Can anyone give us the definition of continuity at a point?
the
And then
value is equal from both sides.
the limit is equal from both sides. Okay, what else?
Instantaneous constant.
Is the value of function?
Yes, very good. So let me write this for you. This is a super important definition. We cannot forget this. The limit from the left of A must equal the limit from the right of A and must equal f of A. That's why I'm begging my students to redo the notes and watch the video, because you will stick if you do that. Okay, moving on. So I like to look at some graphs here. Okay, so consider the function f graph below. Find each limit if it exists. Now, can anyone tell us where is this function not differentiable? Not differentiable, and why?
Are you talking about the graph?
Yes. When is this function not differentiable? So let's start from left to right. Is it differentiable at -5?
No.
Perfect. Why?
Because the limits don't.
Because
the
the
limit.
function is
The function
not,
Does not exist.
the function is not,
Exist.
the function is not
Continuous.
continuous. Awesome. The function is not continuous at -5. Therefore, it's not differentiable. Awesome. What about at -3? Is the function differentiable at -3?
Yes.
No.
No, because the function is
Not continuous.
not continuous. Is it differentiable at -2? No. At 1?
No.
At 4?
No.
No. But what about at -1 or 3?
No. No.
Y is
Just-
not differentiable at -1 and it's not differentiable at 3. Awesome. Why not?
Negative one. Is that
It's a
correct?
corner. It's a corner. It has two tangents, one on this side, one on this side, one on this side, one on this side. So when it has corners, the function is not differentiable. What about at this point? Is the function differentiable at this point?
Yes.
I'm showing a vertical tangent. So you remember a vertical tangent, what does it mean?
Undifferentiable.
It's not differentiable when it has a vertical tangent. Right here, it appears to have a vertical tangent. Okay? In an event, obviously, it looks like a tangent on this side and a tangent on this side, and they don't appear to be the same. Good. Okay. Do you want to work on any of the of these limits? Because I would like to look at actual limits. We know how to read, right? The limit from the left, the limit from the right. We know how to read these, right?
Right.
Okay.
Yes, ma'am.
Okay, perfect. Let's move on. I like to look at some limits, review limits. Like something like this, 20, 22, 21. So let's choose.
21.
Okay, very good. So let's start with 21. So in 21, we have, very good, limit as x approaches 2 from the right, from x minus 2 over x squared minus 4. Awesome. Good pick. Okay. So what do we always do when we're asked to find the limit? What is the starting point?
First, we plug it in.
Yes, we have to plug it in. Awesome. Okay, very good. So when you plug this in, what do we get at the top? I'm going to write it right here on top of the equal symbol.
0.
Very good. What about here?
0.
Oh, perfect. So there is hope. As you know, there is no guarantee. What would you do when you look at this function, the limit of this function? Please remember, do not drop the limit operator till the very last step when you are ready to write, I don't know, 3/7 or whatever. Good. So when you look at this function, what would be your next step?
Simplify the x squared minus 4.
Yes, but how do I do that?
The difference of 2 cubes.
This is not a
not
cube, but a
cube,
different.
but
Yes.
square.
Good. How do I factor that?
X minus 2x plus 2.
Awesome. And then I'm allowed, only now I'm allowed to simplify. Now let's plug it in again. Where does the numerator go?
1,
Perfect. Where does the denominator go?
2, 4, I think 8.
That's it. So then I don't have to do anything. The answer is 1/8. It's a number. It's not 0/0 and it's not 5/0. Good job.
Why
Okay.
did you get 8? I thought 2 plus 2 is gonna be 4.
Yeah, but multiplied by 2 is 8. Is that okay?
Can you
Oh, yeah.
explain that?
Say that again.
Could you explain that how you get 8 a little bit more in depth there?
2 plus 2 is 4. 4 times 2 is 8. When we apply the limit, we replace like we did here initially. So we apply the limit. The numerator is 1. The denominator is 8. So that's the final answer. Is that enough? Is that better?
Yes, ma'am. Thank you.
Excellent. Anyone else has questions on this? Okay, let's look at 22. We have the limit as x approaches 0 from 7 over x. Perfect. Okay, so what do we do? We're asked to find this limit. What will be the first step?
Plug it in.
Yes, the numerator goes to 7 and the denominator goes to
It's not.
0.
good. Trouble. Because we know a number over 0 has 3 possibilities. So now we see something very important, that this is from either side, and it's trouble. If it's from either side, then I have to determine the limit of 7 over x from the left, and I have to determine the limit of 7 over x from the right. I don't know what to write here. Can anyone give us the answer for this and the answer for this?
Are they both 0?
Doesn't exist.
So one more time. When we have a number over 0, we have 3 options. Only these 3 options. Either infinity or negative infinity or DNE. So please do not say 0.
I think 7 over
So-
x to the power of 2.
So what is the answer here?
Is it infinity?
Say it again.
Infinity
0 from the left.
doesn't exist.
0 from the left. Give me a number extremely close to 0 from the left.
It's not negative infinity.
That's it. Can anyone give us this answer?
That would be positive.
Excellent. Now, can anyone give us this answer?
Does not exist.
Perfect. Please do not say 0. Please, I'm begging.
Sorry.
Please, I'm begging you. I don't mind saying. I didn't need that apostrophe. I am begging you. I'm the queen of begging, students. I perfected the art of begging. Good.